Right, example 2. A particle of mass m is pushed up a smooth slope by a force of magnitude 5g newtons, acting at 60 degrees to the slope. This causes the particle to accelerate at 0.5 meters per second squared up the slope. Show that m equals 5g over 1 plus g. So this is the diagram given in the example. It's totally fine to leave it like that, and I think some teachers may disagree with what I'm going to say next, because I think they quite like forces to be pointing at where they're acting. But I actually quite like all my forces coming out of a point, and then it becomes more of an equilibrium question like you were doing last lesson. So what I would personally do with this, but don't feel like you have to, is I would actually take this force and just put it in that way. It's still going to be at 60 degrees to the slope. And sorry, that doesn't really look like 60 degrees. And that's 5g. And then if we think about the other forces acting on the particle P, mass is m, so we've got weight acting down, which is mg. And we also have the normal reaction force, which is acting perpendicular to the slope. So we know that it's accelerating up the slope. So normally acceleration, you just do a double arrow, and that's 0.5 meters per second squared. So we really want to resolve in the direction of motion, which is parallel to the slope. And we want the positive direction to be in the direction of motion. So I'd also make that direction your positive direction. It just makes life easier. So we're going to resolve parallel to the slope. So acting in this positive direction, parallel to the slope, so I can make a right angle triangle here. 5g is on the hypotenuse, so it's 5g cos 60 will give me this bit here. So the component of that force acting in the direction of motion. So I'm using basically F equals ma here. And the thing to remember with F equals ma is F is a resultant force. So I need to find the resultant force in the direction of motion. So I need to take away the component of this weight force that is acting in the negative direction. So I'm adding a negative basically. This here is 30 degrees. So we saw that in the last example. And you'll find after all, you probably don't need to write that in, but that is 30 degrees there. And so this component here is mg sine 30. And then this is perpendicular, so won't affect motion. And that's equal to the mass times the acceleration, which is 0.5. Tidying that up, we get 5g over 2 minus mg over 2 is equal to m times a half, which is m over 2. So 5g minus mg equals m. 5g is equal to m plus mg. I want to make m the subject, so I'm collecting all the m's to one side, and then I can pull m out as a factor. So hopefully you're good with that bit of algebra. We've seen that a few times now. And so m is equal to 5g over 1 plus g as required. So resultant force for F equals ma. Right, last example on this. It's kind of similar really, but we've got a particle P of mass 2 kilograms, and I've got my wobbly board. It's been pushed, no, hang on. It's moving on a smooth slope and is acted on by a force of 4 newtons parallel to the slope, as shown in the diagram. The slope is inclined at angle alpha to the horizontal, where tan alpha is 3/4. So this happens a bit in questions. You're not actually given the value of alpha. You're given that tan alpha is 3/4. Please try not to do shift tan 3/4 to get alpha and then do sine alpha, because you lose your exact form and you'll end up with a decimal. This one might not be so bad, but normally you will. So instead, I'll show you what to do with that. Again, I would write this force coming out of the point instead, but really up to you on that one. And if you're happy not doing that, and that's what you do in physics or whatever, then go with that. But I prefer just everything coming out. So that's 4 newtons. Really similar to the last question. So I've got the weight going down, and I've got the normal contact force. And we don't know which way it's moving. So it might be moving down the slope, because the weight might be more, you know, the component of the weight in this direction might be more than 4 newtons, or it could be going up the slope and the weight's just sort of slowing it down slightly. So we don't know. And in that case, you just need to take your positive direction one way or another. So I'm going to take, just be clear in your head about what you're doing. I'm going to take my positive direction as being up the slope, because it feels like it's being pushed or pulled up a slope there. And I'm going to resolve parallel. So this is really similar now to the last question. So we've got 4 minus, and then here I've got alpha, and I want this component here. So it's 4 minus 2g sine alpha is equal to the mass times the acceleration. And this is where what you need to do from here is, if tan alpha is 3/4, draw a right angle triangle. This one's a bit easy in a way because it's a 3, 4, 5 triangle. But alpha there, opposite over adjacent, and then use Pythagoras to find the hypotenuse. And so sine alpha is equal to opposite over hypotenuse, which is 3/5. And then you can keep your exact form, which is just a bit tidier really. I mean, in a way, you know, we are approximating because of g, but try and get into the habit of actually keeping your exact form through here. And so we've got 4 minus 2g times 3/5 equals 2a. And if you work that through, a comes out as minus 3.9 meters per second squared. Because a has come out negative, that means it's accelerating down the slope. So because I know that's my positive direction, the acceleration is in a negative direction. So the particle accelerates down the slope at 3.9 meters per second squared. Okay, so that should be enough for you to do a few. Yeah, and then we can introduce some friction as well.